Welcome to my video lecture on electrical machines, paper code PCE 501. This total syllabus is based on knockout curriculum. In this lecture, I will highlight about principle of operation of synchronous machine and its synchronization with infinite bus. In my previous lecture, I have already started with synchronous machine. And I have already introduced what this synchronous machine is basically, and where it is used, and how the synchronous machine can be synchronized. That part I will tell you in this lecture. Basically, synchronous machines are generally used for industrial purpose, and industrial purpose means huge amount of voltage needs to be generated, and that should be delivered, and for this purpose a huge grid system should be connected. That means a larger number of synchronous machines need to connect it. And while we are connecting multiple number of synchronous machines together, definitely some principle or some conditions should be maintained. Otherwise it can create a huge damage or huge disaster can happen if we connect the synchronous machine without synchronization. How these things can be possible, that I will highlight in this lecture. Myself, Rubun Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Sudhir Chandra Sur Institute of Technology and Sports Complex. Formerly, it was known as Dr. Sudhir Chandra Sur Degree Engineering College, and it's under GIS Group. So let us proceed with my lecture based on principle of operation and synchronization of synchronous machine with infinite bus. So, what is the principle of operation of synchronous machine? Apart from all other machines like induction motor or DC machines or single phase induction motor, synchronous machine is much advanced version of those machines. That means when we are talking about DC machine or induction machine, it is much more simpler in construction, but when we are talking about synchronous machine, its construction is quietly complex, and it is a larger megawatt machine. It has huge capacity, and it has also maintains high efficiency. Definitely the cost of the machine will be also very higher. So this kind of machines are generally used for industrial purpose, for voltage generation. Whatever amount of voltage we are getting from the power stations, that voltages are generated by synchronous generator or alternator. So, synchronous generator has DC winding on its rotor. Pair of poles are formed in the rotor are as shown in figure. See, here the rotor construction is shown. One north pole side, another one is south pole. Okay, this is the rotor part. And in stator part, we have shown that A, B, C, 3 phase 3 coils are connected together. That means in stator part, we have connected 3 phase supply, and the rotor is made with DC coils, and 4 pairs are formed as per the figure. Hence, there may be 2, 4, 6 pole machines. They have 3 phase windings A, B and C, and placed in the stator slots. These identical coils are with their axis at 120 degree to each other. During rotation of the rotor, its north pole and south pole pass by stator winding A, B, C alternatively. See here, this is our rotor part. Here I have shown it is two poles. That means one north pole, one south pole. When this part is moving, this is our stator coils. This is stator. Here stator coils are present. This is another stator part. Another stator coil present here. Here another stator coil, another stator coils are present here. That means whenever this rotor is moving, it will cut the flux for each stator coils individually. And in this stator part, A, B and C, three-phase supply is given and their nature is 120 degree phase shifted. That means for each cutting, 120 degree phase shifted cutting of flux will be happen. Because the flux created by the stator winding, they are 120 degree apart from each other. That means the flux which is created due to this three-phase supply, that is rotating in nature, 360 motion, okay, and the flux created by DC supply, that is fixed, and that flux will cut the three-phase flux, rotating flux. Now the magnetic field cutting the stator conductor, and this will induce as a single phase alternating voltage in each winding. So what will happen? A current carrying conductor placed in a magnetic field. That current carrying conductor is three-phase conductors. 120 degree apart from each other, three coils are placed. So these coils will cut by the flux which is generated in the rotor by DC supply, and due to this flux cutting in each coil, a AC voltage will be generated, and as those coils are 120 degree apart from each other, so it will create three different phases, different phase voltages, and which are 120 degree phase shifted from each other. That means the coil A will be connected, then A phase voltage will create. When conductor B will be cutted by the flux, then B phase voltage will create. When C conductor will cut, then C phase voltage will create, and these are 120 degree apart from each other. So they are displaced from each other in time by 1/3 of the time, in which one pole pair passes through one winding. When N pole is crossing a winding, one polarity of EMF is induced, which I have already said. Suppose this N pole is crossing the conductor of A, then at A conductor an EMF will be induced. When S pole will cross the same A conductor, then at the same point opposite polarity of EMF will be induced. Since one cycle time is represented by 360, hence 1/3 of its, that is 120, will be generated at each conductors A, B and C. So the voltages which is created in the three windings A, B, C are shifted by just 120 degree. Since crossing of one rotor pole pair across the stator phase conductor produces one cycle of EMF in that phase. If there are P poles in a rotor, then P/2 cycle of EMF are induced. Okay. If there are P number of poles in a rotor, then P/2 cycle of EMF are induced in each phase per rotation. If the rotor speed is ns or ns rps, then number of EMF per cycle induced per second in each phase will be, that is F equals to ns into P/2. 2 number of cycles per second. That is frequency. So, the speed of the rotor is ns. P by 2 cycle of EMF are induced. That means the frequency will be ns into P by 2. And if I represent that ns in RPM, then it will be capital Ns by 60 into P by 2. That means our frequency is Pns by 120. That means the voltage which is generated, that frequency will be Pns by 120, or Ns equals to 120 F by P, where F is the supply frequency and P is the number of poles and Ns is the speed of synchronous machine. A low speed machine has large number of poles while high speed machine has less number of poles. Remember this one. A low speed machine has large number of poles while a high speed machine has less number of poles. Suppose our speed is 1000. Our frequency is 50. Then what will be our number of poles? 1000. Okay. 20. This one. This is 6. That means the number of pole is 6 when our RPM is 1000. Now, if our RPM is 3000, what will be the number of poles? Similar way, 120, frequency 50. Number of poles, then in this case it will be 6. $600. Then the number of poles will be, for this case, it will be 2. So here, when the speed is 3000, number of pole is 2. When the speed is 1000, the number of pole is 6. That means for low speed machine, it has larger number of poles. Low speed 3000 pole is much more. And when speed is high or speed is less, then the number of pole is high. When speed is more, then number of pole is less. Okay. Now the question comes, how we can synchronize a synchronous machine with infinite bus. Before going to that, the factor is kept in comes in our mind that why this is very important. Why we need to connect the synchronous machine is infinite bus? Because our total electrical system is connected through grid. Through infinite bus, it is connected with larger number of synchronous machines connected together. So when we will connect those synchronous machines together, definitely we need to maintain some certain conditions. Otherwise, a huge damage will occur and our synchronous machine and total system will be shut down, or larger damage can happen. So, to overcome this situation, definitely we need to do some test on synchronous machine to know that synchronous machine is synchronized with infinite bus or not. For these purposes, mainly two methods are there. One is bright and dark lamp method, and second method is by synchroscope. So the bright and dark lamp method that we will discuss here in the simplest form. For understanding the purpose that how the synchronous machine is connected with infinite bus, we will make it in a simplest way to understand that how that bright and dark lamp method can be implemented for synchronization of synchronous machine with infinite bus. So here, let us consider this is the three-phase stator part of the synchronous machine, and this part is connected with a switch, and then one lamp is connected here. In the similar way, in three phases, three switches are connected and three lamps are connected with that each phases. And then the remaining part is connected with the bus system. Here it is the infinite bus system. So the factor is that if there is some phase difference between the infinite bus supply, that means the supply side and the generated side. Generated side is definitely, that is synchronous machine side, and the supply side, that means the infinite bus side. If there is some phase difference, definitely the bulb will get some potential difference and the bulb will glow. That time we have to understand that there is some phase difference or voltage difference, due to that the bulb is glowing. So we have to adjust the synchronous machine parameters in such a way so that the bulb will be dark. When the bulb comes to dark, that means the machine is synchronized. Then we will operate the switch. We will close it. That means the machine will be connected with the synchronous machines will be connected with infinite bus, and it is synchronized already. So let us see. There is a phase difference between supply side phasor with synchronous machine phasor. So the lamp is glowing. If the phase difference is 0, all the lamps are dark. In this condition, we can understand that the machine and the bus are same frequency and voltage. So the synchronous switch will be closed. This is the synchronous switch, and this will be closed, and this bulb portion will be just cut out. This will be not present. When it will be synchronized, it will be directly connected with the infinite bus, and the machine will start with connected with infinite bus. But when the machine is not synchronized, then we can vary the field current IDC, definitely field is DC supply, so it is IDC, by varying the voltage and make the both voltages same, and the phase difference between machine and infinite bus becomes equal to 0. When all the lamps are dark, close to synchronizing switch, an incoming machine will be pulled into the synchronism. After synchronization, the motor speed of the incoming machine will be synchronous speed. Okay. So here the main point is, when the machine is not synchronized, definitely there will be some phase difference between our synchronous machine with infinite bus. Then the bulb will get some voltage of phase difference. So due to that, the bulb will be glowing. Now we will adjust the field current IDC, and in such a way we will adjust the field current so that the voltage of infinite bus and our machine voltage, that will be same, and also the phase difference is same. At that condition, there will be no phase difference or voltage difference, so bulb will be dark, and we will operate the synchronizing switch, and the machine will be directly connected with infinite bus. So that is the main thing to understand, that how we can connect the synchronous machine in infinite bus. So this is the simplest version to understand that how we can synchronize the synchronous machine. So up to this is for today's task. So here I have discussed the principle of operation of synchronous machine, and also the synchronous machine operation with infinite bus, how it can be operated. And the main thing is, synchronous machine is basically doubly faded machine. So in part of the rotor we are giving the DC supply, and in the three-phase coils are connected in stator side. From their stator part we are getting the three-phase voltage, which are 120 degree apart from each other from the stator part. So that principle we have seen here, and then we have discussed the synchronization path by using bright and dark lamp method, and here we have seen the voltage should be same and the phase difference should be same. These are the essential necessary conditions for synchronous machine to connect with infinite bus. So we have to maintain these two conditions, and the machine will be connected in the infinite bus. So thank you all for listening my lecture.